All right, sweet. Um, Hi, Professor. This is my video validation. Here's my ID. Bring it close up so it's focused. I'm Haik Abedian. So, hi, Professor. This is my video validation. Here's my ID. Bring it up so it's close. Haik Abedian. So, for the video validation, we're given a problem to solve. And in this problem, we are given. Hi, Professor. So this is my video validation. Here's my ID. I can hold it up close. It's not focusing. For Haik Abedian. That is me. Okay. So we're given a problem for this video validation. And the problem is that we have an island that is 3.5 miles away from the nearest point on a straight shoreline. And this point is 8 miles away from a power station. And basically, we have a utility company that they want to lay electrical cable underwater from the island to the shore and then underground along to the power station from the shore. And we're given some values here. We want to assume that 2,400 a mile is our underwater cost and 1,200 a mile is our underground cost. So clearly underground is much cheaper than underwater. We can use that. So it's asking what points should the underwater cable meet the shore in order to minimize the cost of projection. So we're going to do a cost function here. I don't know why I drew like that, but okay. So this, we have some values here, but we're actually missing some, as we can see. So we have the 3.5 from our distance, and we have the 8 over here, but we need a couple more distances so we can make our cost function. So we are looking for this distance right here, which is our x. And this distance over here would be, if this is x, this would be 8 minus x. So just simple Pythagorean theorem. We can just set up a quick little function here. So we have our 2,400, and we're going to multiply this with square root of x squared, which is there, and that to our 3.5, the distance to the island squared, and add it to our 1,200, which is our underground cost. I'm going to multiply this with the distance, so 8 minus x. So that is our function we have set up so far. We can even simplify it with the 3.5. 2,400 squared plus this would be 12.25 plus, here, actually, I'm going to multiply this as well. So 1,200 times 8, which gives us 9,600. 9,600 minus 1,200 x. Perfect. So the question's not asking for this function, it's asking for the derivative, which is the minimum basically, because we want to find the lowest amount. So let's set that up. So we have our 2,400. Okay, and then I'm going to bring this down here. So let's set up the derivative. So 12.25. And we cannot forget our, there we go. Minus 200. Okay, we can actually get rid of these because those cancel out. We're left with 2,400 x divided by square root of x squared plus 12.25 minus 1,200. So the rest is just solving basically, just breaking it down. We have the right idea. Now we're just gonna solve it. So it's going to be 2400x. What was it? 2400x divided by square root of x squared plus 12.25 minus 1200. All right, so the first thing I would do is multiply this bottom half over here. So 12.25. We do one thing to one side, we do it to the other. 12.25. So that would just get rid of that. 2400 x actually we want to make this equal to 0. So this is equal to 0. I'm just gonna erase this. Oops. Okay, we're gonna make this equal. We're gonna make this function equal to 0. So let's start with the 200, 1200. Then we're gonna have 2400x divided by squared plus 12.25 equals 1200. Then what else do we have here? We can multiply this, the x squared. Sorry, it's a little messy. 12.25. And then this would go on this side. X squared plus 12.25. Okay. So these would cancel out, of course. We have the 2400x equals 1200. And then we have our x squared plus 12.25 in the parentheses. What else can we break down? Let's see here. So we can we can square this. Actually, I think it would be better to divide. Yeah, that would make a little more sense. Okay. So this will leave us with 2x plus 12.25. Okay, this looks a lot simpler than before. What's left? So we have a square root. Let's get rid of the square root. Square this, square this. That would get rid of, oops, this is not 2. This is 4x squared equals x squared plus 12.25. Is that correct? Okay, and then we have our x squared. We can just subtract this. 3x squared equals 12.25. So let's divide by 3. X squared equals 12.25. Yeah, 4.0833. I'm just repeating. And then we would do square root of this, square root of this. So 4.0833. 4.0833. There we go. Okay. So 2.02071. So we can just call it 2.021. So that is our x. But that's not actually what it's asking for, but we can use this to get what it's asking for. So what it's asking for is to find that distance, the 8 minus x distance. Now we have x, so we do 8 minus 1.2, what was it? No, it was 2. 1.2.021. Yes, so we have the 8 minus 2.021, which equals, so we have, so the what we're looking for, so what we're looking for is the optimal point where the underwater cable should meet the shore, and that's going to be approximately 2.021 miles away from the nearest shoreline point. So that means the underground cable distance is going to be 8 minus 2.1, so 8 minus 2.021, going to give us 5.979, or it's 5.98. So that would be the distance of our underground cable. But obviously our optimal point is 2.02 miles away from the nearest shoreline point. And we obviously have to graph it on Desmos. So here's the graph. I already have it set up here. I just input the cost function. We got our little graph here. And we can see that this bottom point right here is actually what we got for x. So our minimum value, so 2.02073. Yeah, so basically the same thing. So it's gonna wrap it up for this problem. Yep, and that's it. Yes. And yeah, so that's gonna wrap it up for the problem. Thank you for watching. I hope you enjoyed.